Hello, I'm Jeremy Ellis, Canadian robotics machine learning high school teacher, and I'm going to talk about FOMO observations from the toy cars my Gearbox group has been working with. We switched from the Nano 33 BL Sense with its camera a few years ago. We just wanted a little bit more power, and the Portenta with Vision Shield right down here um, allows us to view what we're analyzing on a grayscale OLED. So first thing is FOMO, the one we're using, is grayscale. And so even if you have a camera, even if you have incredible resolution, we're working with 96px by 96 pixels in grayscale. So FOMO, the first observation is it's fast. And that is so needed for the cars. As the car gets faster, the analysis needs to be faster. So let's just have a quick look. Now notice that reflection there. That's a huge issue. So FOMO can have false positives. So the second observation is FOMO can give false positives. And in your application, can it handle false positives? So here's a counting application with the minced numbers, and it's doing okay, but if you look at it slowly, it is actually having false positives and false negatives. So here it's counting up all the zeros and the ones. It's doing an amazing job for a microcontroller. Note that that was trained on the Professional Edge Impulse 2000 training cycles. Um, with object analysis, the third observation is when you're using FOMO, can you change a 3D object into a 2D object by having it lie flat, or any way you can get away from having to know all angles of that object? Here's something that's actually trained okay, but was really hard for us to work with. We originally
Just
had pop
got
models.
FOMO with that gym pulse working. Look how
It's going
quickly
okay, but
this analysis is
in
happening.
reality, it had too many errors. Um, with analyzing objects, can you orient them in one direction? So a leaf that has a definite shape,
Yeah, it's
can you
changing.
always analyze it with that definite shape? Lighting, reflections, huge deal for us was figuring out that reflections were causing false positives. Sunglasses seem to help briefly. Toy robot car, with our analysis with the car, we could choose what we wanted to analyze. And some things are easier to analyze, especially with the free Edge Impulse subscription, where you're, 300 images, how many training loops? There's a bit of a problem there. Our fourth observation is if you can't control the object orientation, um, what about symmetry? Like, would a star, a circle, things like that be better to work with? Fifth observation is best. We found it best to detect one thing. And remember, we're going with cars that, as it works, we want them to go faster. By the way, you can go over the 10 default observations. So here's what we looked at. There's the URL for its fast Fourier transform. This is kind of what FOMO sees. And all these images have different fast Fourier transforms. And it's worth having a look at that page. Now, when we started collecting our data, we tried to use the cell phone to collect the data, taking the pictures. Um, but it wasn't ideal. And then we tried connecting the cars, the Arduino Portenta H7, with web USB, but the cars are moving and you've got your laptop there. So what eventually worked for us was taking ping images and saving them to the SD card on the Portenta Vision Shield. I made a program. This is my Portenta Pro Community Solutions. .3 is the Vision Shield. .36 is camera pings. .362 is the one we used. We changed the speed. It was taking a picture every 10 seconds. We changed it. So for testing, you can download your model to the cell phone. You can download Wasm and I have a link there to using WebAssembly. You could look on the OLED screen that we've hooked up to the Potenta, or realistic environment testing. So here's some fails we had with using pop cans. Notice those reflections there? So this was quite fun. Great that the cars were actually moving, but notice how slow it's going. We eventually had some success. One of the cool things one of my students did, first of all, I came up with these 3D printed discs that worked well. Look how fast this is going. But this student created a reverse, and he's got the lights, and we're on carpet. So that was pretty exciting. We're having some success with getting an RC backup controller. We did a lot of things with LoRa and trying Wi-Fi and things like that. So that's going well. And here's where we're at the moment. Notice the better speed. And we're using the disc. Instead of the 3D printed discs, I came up with these just photocopied double-sided discs. The colors, just I ran out of paper. So that's starting to work pretty good. It's got some speed, it's reacting to things. We're pretty happy with it. It's a single speed for the car though. So, conclusion, Edge Impulse Vision FOMO model is an excellent tiny ML teaching environment. Lots of room for improvement with vision analysis when you consider things like number of classifications, orientation, symmetry, reducing reflections. My students and I have worked on various issues and solutions for using constrained devices with the free version of Edge Impulse as a processing time limit of 20 minutes, about 300 images. And see you, it's Jeremy. And I didn't want to do that.
Okay, so Jeremy's here. Do you have any questions for his first presentation? I think, Jeremy, there's one from Segun. Let me see if you're. Oh, sorry. Now you can activate your camera, Jeremy. So from Segun, which is asking about the advantage of using the Portenta over the Nano.
Am I on?
Yeah.
Okay. What's the advantage? First of all, it's dual cores, so you have the option of using 2 cores. It has this extra 8 megs of SD RAM, which allowed us to use a grayscale, the little monitor you saw, which was super useful for testing. Potentially the Nano could do the same thing. We'd have to test it out. I don't actually have the ML kit, so I can't test out what you guys have. Can you do kind of Hydra? That would be better answered by Sean or one of the Edge Impulse people. I'm not sure with
what is the answer? The question you're tackling now?
This is Andrew's. Is FOMO multimodal? So, Marcelo, can we go on to the next video? Because we've got a bunch of videos to go, and then I can answer more questions, or even during the chat, I might be able to.
Sure. Let me go.
Okay, so what this is it's a web serial. Marcelo, a friend, was mentioning, how do we get information onto the onto Edge Impulse? So there's my GitHub, and here's just the main website. And this one at the bottom here, Resistor, it's a web page. You can load this exact same web page. But what's interesting about it is the connect via serial port, where we've got the Nano 33 BLE connected. And right there, I'm just proving that the little LED can be turned on or off. And what we can do with this is we can start grabbing sensor data. And so right there, I've got a potentiometer at the bottom of the screen, and it is showing a timestamp and then the value. And so pushing the start button and the first line button gives you some general information. We can also change the frequency. C10 is your total time that you're analyzing data. You could also M9000 for total time in milliseconds. And then you've got frequency. You could do frequency or a delay. They're kind of the same thing. They're inverse of each other. And so you can control this data set. Very similar to what you can do connecting your device to Edge Impulse, but you could slow things down a little bit better than what you can do with Edge Impulse. But the big deal here is that we can make a CSV file. And CSV files, A, you can look at the data, and B, they're very simple to upload to Edge Impulse, and I'll show that. So what we do is we make the label name of your CSV file there. So I've called one low. I always put a number in front of my labels. And so that's grabbing the information. And this button here, the auto clean save start button is, you might not be able to see my mouse. I'm gonna have to use that mouse. So what we're doing here is we're sending the data, and I'm going to have to work with the mouse that's on the screen. And so he's sending start, change the label again, and auto clean. And so now every time we push auto clean, it's downloading a CSV file. There it is. Okay, you just saw it at the bottom of the screen there. And they all have the same name because these ones, it's for classification, vision classification. They all are going to have the same label. And I'm just moving the potentiometer a little bit. Then you would change the label and continue on. So it's just a really quick way of making a bunch of CSV files. It's web-based. You can load up this web page and grab the code to put on the Nano 33, and it should basically work. I'm not quite sure if it works on Mac, but I don't see any reason why it wouldn't. So here is what it's making. It also cleans it because every once in a while you get a blank row. So there's a little clean, or the auto clean save start button. So here's Edge Impulse, and there's the upload button. You don't have to use the CSV wizard because everything's properly labeled in a CSV file. So I'm just grabbing a bunch of files. Let's see if I can grab all of them. There we go. And uploading the data. And there we go. It's uploading a ton of data. And hopefully I go into, there's the data set. Notice I've been moving the potentiometer a little bit to try to estimate what real data might look like. And I've also trained with the potentiometer moving up and the potentiometer moving down. What are we looking at here? Looks like I'm talking a lot. So there's the Nano 33 with the potentiometer. Note it's quite simply hooked up. It's just a power, ground, and then probably to AO. This is talking about the file on the Nano 33. Now this one's quite big because I'm doing a bunch, but it probably could be reduced down. Here's the main loop that's analyzing a few things. I should go down to some code that's just there. So the first line button, it's just reading the first line, and then it's showing a timestamp and whatever value is in A1. Once again, we're just giving other options for how to do some of the things that Edge Impulse does. Because sometimes it doesn't work for you in the classroom. So here is my final model, the confusion matrix, which this one isn't beautifully trained, but I'm just trying to demonstrate what this can do. So your typical thing is you'd go to Arduino and you'd build it on the Arduino. What I'm doing here is I'm building a WebAssembly file, and I'm going to put it on the same location that the web page is that was doing the analysis. And so this is an extra step because we can do web serial. Let's see if we can push it to its limits. And my next video is going to be showing you some output with a little web serial. I find students are a little bit more comfy with web pages. And so anything I can move over to the web is better for them. So I think my screen is in the way. We're just downloading that web serial and then extracting it. And yeah, my page, it makes a browser and a node. It's the browser files. You can just see them in the corner here, that you upload to the web page. And on the web page, once you've got all those files, so it's in my public folder, it's in the A5 folder, you've got my main one, the top one, AO resist index.html, but now we've got all these WebAssembly ones from Edge Impulse, a JS file, a WebAssembly file, an index. And the index typically is not terribly useful because it needs raw data. And so that's what you would get from Edge Impulse. And if you paste some raw data in there, it will analyze it. So what I've done is I've figured out a way to paste the raw data from the potentiometer. And let's get this potentiometer going. You have to connect it again. Just check things here. And what we're trying to do is get that raw data sent to the Nano 33. And so, no, sent to the WebAssembly from Edge Impulse. And so here we go, there. So this one was high. High is strangely on the left of the potentiometer. Now that kind of stuff, an Arduino could analyze all on its own. What gets harder is when it's going up or when it's going down. And so here, auto-analyzing, and I'm moving it. That one was high. Now I'm moving it up and down. There we go. So going down, it got it at 99%. Going up, it got it at 99%. So this is just a really quick way to test your Arduino code before spending the 15 minutes compiling it and going from there. You know, you can just test it out and see what you think of the values. It does take a little bit of JavaScript, but this one should work right away as long as you got a potentiometer hooked up to the right thing. We can stop that, Marco. And I'm really hoping my next one has some sound to it. That's my mess up. Any questions about those two? Because I'm not sure how I'm doing for time. Share the video.
Let's go. Should you go to the next one?
Yeah, and I can share a bunch of links to the videos, but I've got a funny feeling there's no sound on those videos either. That's my mess up. I should have tested that.
No, there's audio. There's audio.
Perfect. Perfect. Thanks for testing.
How
are we for time? This is only a 5-minute one. This is the next step.
Yeah, so let me just check if I'm sharing it with audio. Yes. Okay.
Hello. Hopefully today you've done some web USB with Edge Impulse, used web USB or a subset of it called web serial to get some data files in CSV format from your sensors. This one, I want to branch out a little bit, do some more web serial. The nice thing with web serial is there's my main line. If I'm reading in, and this time we're going to output from a web page to, in this case, a Nano 33 and a servo motor. Got some batteries there in the servo motor. just has some information on it. And quite an easy bit of code, the meat of the program. If it reads person, it attaches the servo motor, it serial prints person, it writes 90 degrees, and it waits for a second. Whereas if it sees a pin, it writes to the servo 130 degrees. So this has come about with, first of all, this is my web ML serial page. That'll take you to the Git Pages site. We're doing this one, the Hugging Face. Now let's talk, if we go to Hugging Face, just recently Hugging Face allowed JavaScript to access its machine learning data sets, and it has a ton of them. You should definitely look through it. So this is my page showing some of these things, a whole bunch of text, machine learning. Now this is all sending to the cloud data set, which is then sending information back. I have some audio analysis, image analysis, and then this one, text to image, you should definitely look at. This one's the object detection, and when I go to that, it'll be similar to this page, but it won't have this little button, connect via serial port. So that's what we're going to do right now. We have the code loaded up. Let's test the code first. Always do a LED test. I've got offer on because on the Portenta, it works the reverse, but let's just see what's going on. Oh, I haven't connected. So we connect, web serial, check. Okay, that did turn it off, and that one turned it on. And let's show you what, basically it's a good idea to test your stuff. So if I test for person, it turns to person. If I show unknown, does unknown. And now this web page simply does the thing that the Hugging Face JavaScript page does, and that is it either loads an image from the internet. Let's try one. Let's load that, and all you do is click on that and load image, and it gives me my data, and there we go. It's moving to dog and unknown. Oh, and cat. So it seemed to find a dog, a cat, and it somehow found either two dogs or another cat. I have this set up on my webcam, so there I am. Let's throw in a picture beside me and see what happens. And it'd be nice if I could page up quickly. So I take that picture and then page up. And what's it doing? It sees a person, unknown. And oh, it only got the person. It didn't grab the picture this time. Let's try it with more of a picture. Once again, it's not so happy with the dogs. Let's try the picture. Well, let's try this picture. Copy. So on this page, you can do pictures or webcam. And all I'm showing you here is this connection between the Arduino and a web page and output. So this one's doing cat, dog, and person, which, if we look at the picture, is pretty accurate. You will notice that TinyML would have a hard time with this accurate work. So I like to think of this thing we're doing here, where we're working with the web page, we're working with the internet, we're working with the Arduino, as more what TinyML might be in 3 or 4 years, and it's what ML can do at the moment. Hope you enjoyed it. Have a good day. Okay.
Okay, super. So there were a few questions that you answered already in the chat from what I've seen. And
Great
again,
presentation.
okay. Yeah. So let's start by, round of applause. Great presentation.
Very good.
Lot, I mean, huge potential, right? So as you know, Jeremy is very active on Discord. So if you have questions for Jeremy, maybe the best place would be on Discord, right? Jeremy, would that work for you?
Oh yeah, yeah. I think my username might be Jerteach on Discord, and you can follow me on Twitter at Roxetta.
Yeah.
A lot of this. How much time do I have, Marco?
I think we're
done?
over. Yes,
okay.
we're done.
Then have a good day, everybody. I covered a lot, but we're still working on some of these things. Thank you.
The videos are available, and your GitHub is super rich, right? So all the tutorials are there. Super fantastic. Thank you so much.